This is the Chapter 4 exam review. Problem number 1. Perform the indicated operations and indicate the degree of the resulting polynomial. So it looks like we're subtracting these two polynomials. So I'm going to change the sign of everything in the second parentheses and then add it to the first polynomial. So let's do that. So we have 18 x to the 6th minus 5x to the 5th plus 4x minus 2. And now we're going to distribute that minus across. So we're going to change the sign of everything inside parentheses. So that plus 6x to the 6th becomes minus. That minus 9x to the 5th becomes plus. That minus 7x becomes plus 7x. And that plus 13 becomes minus 13. And let's do a little association here. So we have an 18x to the 6th minus a 6x to the 6th. And then we have a minus 5x to the 5th and a plus 9. And then we have a plus 4x and a plus 7x. And then we have a minus 2 and a minus 13. Okay, so let's combine like terms. 18 minus 6 is 12. X to the 6th. Minus 5 plus 9 is plus 4. X to the 5th. 4x and 7x, that gives me 11 x's. And minus 2 minus 13 is minus 15. The degree of that resulting polynomial is a 6-degree polynomial. The degree is the exponent, the largest exponent on any one of the terms. Problem number 2, multiply the monomial and the polynomial. So we're going to distribute that 3x to the 4th across each term inside parentheses. So we have 3x to the 4th times 2x squared plus 3x to the 4th times minus 9x. And then we have plus 3x to the 4th times 6. So we have 3 times 2 is 6. X to the 4th times x squared. We add the exponents when we multiply like bases. X to the 6th. Then we have a plus 3, a minus 9. That's going to give us minus 27. X to the 5th. 4 plus 1 is 5. And then 18. X to the 4th. All right, find the product. So we're going to multiply a binomial times a trinomial. So I'm going to distribute the 3x across everything, and then I'm going to distribute the minus 2 across everything. Every term in one times every term in the other. So we have 3x times x squared plus 3x times minus 5x plus 3x times 6. Then we have minus 2 times x squared minus 2 times minus 5 is going to give us plus 10. Now, let's write that out. So minus 2 times, write it neatly. Let's do this neatly. Minus 2 times minus 5x. There we go. That looks better. And minus 2 times plus 6. Okay, now let's multiply everything out. We have 3x times x squared. So that's going to be 3x to the 3rd. We have plus 3x times minus 5x. It's going to be minus 15 x squared. We have 3x times 6 is 18x minus 2x squared. We have minus 2 times minus 5 is plus 10. And minus 2 times 6 is minus 12. Do I have any like terms? I believe I do. And I have a mistake right here. Maybe you noticed that. that should be 3x to the third. X to the first time x to the second is x to the third. So 3x to the third, and then I have a minus 15 minus 2x squared, that's minus 17 x squared. I have an 18 and a 10 plus 18x, and then minus 12. And I have a mistake right here. 10 and 18 is 28, I believe. I do believe. All right. Find the product, so we're going to FOIL. I have 2x minus 7 times 5x plus 7. So we're going to multiply first 2x times 5x. Then we're going to multiply outside 2x times 7. Then we're going to multiply inside minus 7 times 5x. And then last, minus 7 plus 7, minus 7 times plus 7. Okay, let's multiply those out. We got 10x squared. 2 times 5 is 10. X times x is x squared. Plus 14x minus 35x minus 49. Okay, and then we're going to combine like terms, outside plus inside. I believe that is minus 21x minus 49. All right, we're going to square a binomial. To square a binomial, we multiply the first term by itself. We square the first term, x times x is x squared. We multiply the two terms together, and then we multiply that by 2. So we take the two terms inside the binomial, we multiply those together and multiply that result by 2, and then we square the last term. So that's x squared plus 8x plus 16. Factor by grouping. So we're going to group the first two terms together, and we're going to group the second two terms together. So those first two terms, I think the common factor is going to be x squared. A common factor is always the term of smallest degree. So we're going to factor out an x squared. And what I have left over when I factor that x squared out, x to the third divided by x squared is x to the 3 minus 1. So that's x right there. And then I have minus 6x squared divided by x squared. That's going to give me minus 6. And those second two terms, I think we have a plus 2. 2x divided by 2 is x. Negative 12 divided by 2 is minus 6. Okay, then we can factor out the x minus 6 in parentheses, and we get x squared plus 2. Problem number 8, factor the trinomial or state that the trinomial is prime. All right, so we're going to factor this to the product of two binomials. And the first terms in the two binomials must be x, because x times x is x squared. So we need factors of negative 45 that add to negative 4. Is that negative 9 and 5? I believe so. Minus 9 plus 5. And we would FOIL that to check. X times x is x squared. Outside's 5x, inside's negative 9. Negative 9 plus 5 is negative 4. Negative 9 times 5 is negative 45. All right. Factor the trinomial or state whether or not it's prime. So we have a 3a squared here. So this is going to be 3a times a. Multiply 3a times a, we get 3a squared. Okay, so then we need to figure out factors of negative 20, that when I put it in the second spots and I FOIL it, I get negative 4 for outside, inside. So that'd be maybe negative 4 and 5. So 5 here and negative 4 here. No, that's not going to work. Not going to work. So let's erase that. maybe 5 and -4? No, I don't think that's going to work either. So how about -2 and 10? So 10 here and 2 here. And I think it's actually going to be -10, +2. -10, +2. So let's FOIL that real quick. 3a times a is 3a squared. Outside's +6a. Inside's -10a minus 20, and that will work. So that is the factorization of that. All right, factor completely. So I have a common factor in both terms of 2x. I'm going to factor that out first. And then that second factor there, that binomial factor, is the difference of two squares. So that's going to factor to x plus 2 times x minus 2. And I know that's the difference of two squares because x squared is a perfect square, as is 4. Factor the expression completely or state that the polynomial is prime. I'm going to factor out 5 first. And that's going to be x squared minus x minus 6. And so now I need factors of -6 that add to -3. That's going to be -3 plus 2. I don't know what I just said, but it should be two factors of -6 that add to -1. So that would be -3 and plus 2. Solve the following quadratic equation by factoring. So I'm going to have to move this 18 over here before I can solve this quadratic equation. I have to have it in standard form where I have the quadratic on the left-hand side and 0 on the other. So I'm going to subtract 18 from both sides. So I end up with x squared minus 3x minus 18. So I need two factors of 18 that add to -3. I think that's going to be -6 and +3. X minus 6, x plus 3. Set each factor equal to 0 according to the zero product principle. And solve the resulting linear equations. Excuse me. So we get x is 6 and x is -3. I would do a quick check of that. If I put 6 in there, 6 squared minus 3 times 6 is 18. That is correct. Put -3 in there, -3 squared minus 3 times -3 is 18. That is correct also. Use factoring to solve the quadratic equation. So I'm gonna have to move that 12 over there, so I'm gonna subtract it from both sides. I need two factors of -12 that add to -4. I think that's going to be -6 and plus 2. Then use the zero product principle to set each factor equal to 0. Add 6 here, x is 6. Subtract 2 here, x is -2. I do a quick check, and they both check, they both work. All right, use factoring to solve the quadratic equation. This is a perfect square trinomial, and I know it's a perfect square trinomial because the first term is a perfect square, as is the last, and the middle term is the square root of the first times the square root of the last times 2. So this factors 2. x plus 3 times x plus 3. The other way you could look at this is I need two factors of positive 9 that add to positive 6. That would be positive 3 and positive 3. So set each one of those equal to 0. They're the same factor, so I really only need to set one of them equal to 0. Subtract 3 from both sides, and I get negative 3. Number 15, solve the quadratic equation by the square root property. So take the square root of both sides. And when I do that, I have to put a plus or minus in front of the square root on the right-hand side. And then I'm going to simplify this radical. There's a factor of 4 and 28. So this is plus or minus the square root of 4 times 7, which is plus or minus 2 square root 7. Square root of 4 is 2. Solve the following quadratic equation by the square root property. So we have 4x squared plus 1 is 27. If I want to use the square root property, I need to get the x squared by itself. So I'm going to first get rid of the 1. I'm going to subtract it from both sides. I believe that is 26. Oh, I got a 37. I knew I was making a mistake. You heard me pause. That's a 37, not a 27. $36. Okay, and then I'm going to divide both sides by 4. X squared is equal to 9. So x is plus or minus 3. All right, so by using the square root property, so I have x minus 9 squared is equal to 16. Take the square root of both sides. X minus 9 is plus or minus the square root of 16, which is 4. Square root of 16 is 4. So let's write this over here. X minus 9 is either negative 4 or x minus 9 is positive 4. Add 9 to both sides. So x is either 5 or add 9 to both sides. X is 13. So 5 or 13. Okay, solve using the quadratic formula. So the quadratic formula is x equals minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so a is the coefficient in front of the x squared, so it is 1. B is the coefficient in front of the x, so it is 5. And c is the constant. Now it's a plug and chug. So x is minus b minus 5 plus or minus the square root of 5 squared minus 4 times a is 1 times c is 3 all over 2 times 1. So that is negative 5 plus or minus the square root. We have 25 minus 12, which is 13 all over 2. And that is as simple as that's going to get. So it's negative 5 plus or minus the square root of 13, the whole thing over 2. You can't reduce the square root of 13, so you're done. 19, use the quadratic formula. So a is 5, b is 10, c is 4. I'm going to write it down here. X is minus 10 plus or minus the square root of 10 squared minus 4 times 5 times 4 all over 2 times 5. So that's minus 10 plus or minus the square root of 100 minus 80 over 10. So that's minus 10 plus or minus the square root of 20 over 10. And you can reduce the square root of 20. 20 is 4 times 5. So this is minus 10 plus or minus 2 square root 5 over 10. And then you can cancel a 2. You could factor that numerator, factor out the 2. And then cancel it with the denominator. So you get negative 5 plus or minus the square root of 5 over 5. All right, last but not least, solve the equation by the method of your choice. So let's write this down here. 3x squared minus 2x equals 1. So I'm going to move this 1 over here by subtracting it. And I do believe that's factorable. If I can factor it, I certainly do. So the first terms have to be 3x times x. That's the only way we're going to get 3x squared. And I think if we put a 1 here and make it a minus, and a 1 here and make it a plus, that is going to FOIL correctly. Outside's negative 3x, inside's 1x. Minus 3 plus 1 is minus 2. So we get 3x plus 1 is equal to 0. X minus 1 is equal to 0. Subtract 1. Add 1. I'm not sure exactly what I've done over here. Who knows? Divide by 3. So I get negative 1/3 and positive 1.